Good morning, everybody. In today's class, we'll be looking at past questions and any question I give to you today. If you have not studied for organic chemistry at all, any question we solve today, please use it to read for your exam. Okay? Any question, whether in organic chemistry, whether in physics, whether in physics practical, please use it to study for your exams. If you have not studied at all, why if you still have time to study, I'll still send other past questions that you look at. Okay? So I'm saying this with utmost confidence. All right. If you check the group, Great Minds Academy group, right now, you'll see three past questions, three pages questions there. You see three pages question there. Have you seen the questions? I've seen it, right? So those questions, starting from number 1 to number 6, will be the questions we're going to do today in organic chemistry. And what does it have for it? The instruction says answer any 4 questions. So during your chemistry exam, you have to answer any 4 questions. They give you a total of 6. You answer any 4 of your choice. Okay? And please, I need utmost silence so that I'm able to teach you and teach you well. Okay? So we're going to start from question number 1. Question number 1. What does question number 1 say? Okay, don't worry, I'll read it out. Okay? I'll read it out. Question number 1 says, okay, from the instruction from that number 1A, it says, tick the correct answer. And every question has 1.5 mark. That's every answer has 1.5 mark attached to it. And the first question says, arrange the following bonds. Is that what you're seeing there? Arrange the following bonds in order of increasing bond length. Arrange the following bonds in order of increasing bond length. That's the question. Now, for the answer, the single bonds have longer bond length than the double bond, which has longer bond length than the triple bond. Did you get that? I say single bonds have longer bond length than the double bond, which has longer bond length than triple bond. So that is the answer. Single bond is longer than double bond, which is longer than a triple bond. Just so you know. So among them now, we can choose any of the answers there. Among them now, you can choose any of the answers there. The correct one, just using this my explanation. All right. So that's what question number 1AI. That's the answer. Question number 1AII says, functional groups determine dash. Functional groups determine dash. What does functional group determine? From the options we have there, one of the options says physical state only. The other option says chemical properties of a compound. The other one says color of a compound. Then the other one says melting point only. Now, whenever you see functional group, the functional group determines the chemical properties of the compound. Okay? It determines what? The chemical properties of the compound. So, functional group determine chemical properties of a compound, not physical properties. Okay? So, the correct answer there is chemical properties of a compound. Are you there? Now, the next one is a carbon atom bonded to 4 other carbons is called a carbon atom bonded to 4 other carbons is called. So let's say we have a carbon atom here bonded to this carbon, this, and this. When a carbon atom is bonded to 4 other carbons, that carbon atom is called a quaternary carbon. When a carbon atom is bonded to 4 other carbon atoms, it is called a quaternary carbon. Okay? It is called a quaternary carbon. So the correct option there is quaternary carbon. Now, when the carbon atom is bonded to 3 other carbons, it's called what? Tertiary carbon. Then when it's bonded to 2, it's called what? Secondary carbon. And when it's bonded to only 1 carbon, it's called a what? Thank you. So those are the answers to those kind of problems. All right. So the next question says, dash was the first organic compound synthesized in the laboratory without the aid of any kind of vital force. Dash. Oh, if I'm answering this for me, well, let me just say the question again because the class is being recorded. Okay. Dash was the first organic compound synthesized in the laboratory without any form of vital force. The answer to that question is urea. It is what? Urea. So urea is so this is urea, chemical formula for urea. All right. Urea. Are you there? Are you there? Now the next question says, which of the following best describes a halogenation? Alkene. Is that an alkene? Alkane halogenation. Halogenation is the addition of halogens. And what are examples of halogens? Chlorine, bromine, fluorine, iodine, and so on. So those are what? Halogens. So which of the following best describe the halogenation of alkanes? Now, alkanes undergo a type of reaction we call substitution reaction, where a molecule is removed or halogen is removed and replaced with a halogen. Okay? So halogenation of an alkane is a substitution reaction. Okay? Now, when you go to alkenes, if you halogenate or hydrogenate an alkene, it's called what? Addition reaction. Did you get that? For alkane, it's called a what? Substitution reaction. Okay? It's called a substitution reaction. Halogenation of an alkane is called a substitution reaction. So that is it. So the answer is substitution reaction there. So the next one is question number 6, which says, what is the percentage S character? What is the percentage X character? What is the percentage X character of ethane? What is the percentage S character of ethane? Now, ethane or alkanes generally, alkanes are sp3 hybridized. Okay? Alkanes are what? sp3 hybridized. Now that means that we have a combination of 1s and what? 3p orbitals, right? So from the options there, you can see 20%, 33.3%, 25%, and 50%. Now, because we are having 1s and 3p orbitals, the percentage S character becomes what? 25%. Okay? Now, why is it 25? That is because this P3 gives us 25 plus 25 plus 25, which is equal to what? 75%. So 75 plus 25 gives us what? 100%. So the percentage S character of ethane is 25%. Is 25%. All right. So the next is question number 1B. In question number 1B, they said give the IUPAC names or structure of the following compounds. Give the IUPAC names Give the IUPAC names or structure of the following compounds. And each of them carries 2 marks. Each of them carries 2 marks. So let's start from the first one there. The first compound is in this form. This is the first compound there. They say we should name this compound on the board. All right. So the name of this compound, before we name it, for those that don't know, every sharp point of this structure, like you see here, I hope you are watching what I'm doing. You see here, here, and here. All these points are made up of carbons. So there are carbons at each of these points I circled. Okay? There are carbons in each of those points. Now, this structure, I can redraw it, although you don't really have that time during the exams, but you can draw the structure to be like this. So this becomes a carbon. Of course, this is primary to another carbon to another carbon down here. So this gives us this carbon, and this carbon. Okay? Then these two up and down becomes CH3, CH3. All right. So this up and down becomes this. So this compound is same thing as this. So now I've drawn it in this simple form. What will be the name of this compound? Now you can see, first, we always identify the long chain, right? The long chain here, even though you move this way or you move this way, it's going to still give us 3 carbon chain, right? So it means we're looking at a prop here, right? But there are substituents to the chain, 2 substituents, and the both substituents are all methyl groups, right? Now, the methyl groups are attached to which carbon? So this is carbon 1, 2, and 3. So you can see here that they're attached to carbon 2. Okay, and we have 2 methyl groups attached to carbon 2. And from the IUPAC rules for naming this kind of compound, you are going to, first of all, you write the positions of the methyl group. So this becomes, the positions are 2, 2. Then hyphen, you put di. What group are they? Methyl. Now, now we have indicated the position of the methyl. Now, the next thing we put is what? The parent chain. The parent chain is made up of 3 carbons. So which will give us a what? A propane. Thank you. So this compound is 2, 2 dimethyl propane. So that is the answer to this one. All right. So the next compound is this one. All right, so this is the next compound there. Hope you can see it. All right. So they say we should name this compound. Now, this is a cyclic compound. And how many carbons are in the cyclic compound? Every sharp point, every point here is made up of a carbon. Every point here is made up of a carbon, okay? So now let's count how many carbons do we have here? 1, 2, 3, 4, 5 carbons. Okay. Now, that means that this is a cyclic ring made up of 5 carbons. But we have a substituent attached, okay? The substituent is attached to this carbon here. Now, when we are naming in cyclic ring, we can choose any point we like in this case now, we can choose any point we like as carbon 1. Okay, it's not like we must start from here. It's not like we must start from here to say it's carbon 1. So this point the substituent is attached to is carbon 1. I hope you're following. So because at carbon 1, we have a methyl group attached to it, this compound is then methyl, then cyclo, then how many carbons ring? 5. So it becomes cyclo what? Pentane. Methyl cyclopentane. Now you can go ahead to put 1 methyl, but is there any need? No need. So that's why I left it as methyl cyclopentane. So that's the answer to this problem. All right. So the next one is they gave us a name, and they said we should draw the structure. They gave us a name and they said we should draw the structure. All right, they gave us a name. The name is 1, 2, 4 trimethyl cyclohexane. 1, 2, 4 trimethyl cyclohexane. So they gave us this name and they said we should draw the structure of this compound. Okay, so when you are given a name, you look, is this compound a cyclic compound? Yes. If it's a cyclic compound, how many carbon ring are we having here? 6 carbon ring, right? So we have to, first of all, we draw the 6 carbon ring. So we're going to do that. So the first task is to draw the 6 carbon ring. Now, when we draw the 6 carbon ring, we now take cognizance of the substituent. The substituent is already telling us that we are having 3 methyl group attached to the ring, right? And they are in position 1, 2, and 4. So where are we going to choose as position 1, where are we going to choose as position 2, and where are we going to choose as position 4? Well, this is, I will use the word idiosyncratic. It is just for you. Anywhere you choose as position 1, you can use from that point to start getting your position 2 and 4. So in this case, let me just choose here as my position 1. So it means at this point, I will choose my position 1 and put CH3. This becomes position 2. Again, I'll put CH3. But position 4. Now, this is 1, 2. This is going to give us what? 3. Then this becomes what? 4. So, CH3. So, with this on the board, I'll draw my 1, 2, 4 trimethyl cyclohexane. All right, so question number 4. Question number 4 says we should draw 2, 2, 4, 4 tetramethylpentane. 2, 2, 4, 4 tetramethylpentane. All right. So to draw this structure, once again we're going to look at how many carbon ring are we looking at? 5 carbon rings. So we try to draw a 5 carbon ring. So this becomes all right. So they said that the methyl groups is a carbon 2 and carbon 4. So anyway you name number, let me use this as carbon 1, 2, 3, 4, and 5. So 2, 2 simply means I should put 2 methyl groups in carbon 2. So in carbon 2, I'm putting CH3 up and CH3 down. The same thing I'll do in carbon 4, CH3 and CH3. All right. So is there any carbon that is not fully distributed? Yes, carbon 3. So over in carbon 3, I'll put H and H. So with this, I've drawn 2, 2, 4, 4 tetramethyl pentane. So this is the structure of that compound there. All right, the next question is question number 2. 2A, instruction says, tick the correct answer. Each question carries 1.5 marks. The question number 2AI says, 1,5 hexadiene. 1,5 hexadiene is an example of dash. 1,5 hexadiene is an example of dash. Now, from the options, we are seeing conjugated diene, cumulated diene, isolated diene, and aromatic as the last option there. So to understand whether it's conjugated, cumulated, or not, let us draw the structure on the board. So hexadiene simply means we are dealing with 6 carbons. All right, 6 carbons, and the diene is at, so I'll give this carbon 1, 2, 3, 4, 5, 6. And the diene is 1,5, so it comes here and here. All right, so this becomes 1,5 hexadiene. All right, so permit me not to distribute the hydrogens because it's not necessary at this point. So I don't want to distribute the hydrogens. So now we are having this structure. So this is like the almost complete structure of the 1,5 hexadiene. Now, we have 3 types of dienes. We have the conjugated dienes, we have isolated dienes, and we have cumulated dienes. Okay? Now, when you hear conjugated dienes, means that after one double bond, there is a single bond, then another double bond. So let's assume this structure had something like this. Let's say this structure has another double bond here. Now let's ignore this one. For conjugated diene, you see something like a double bond, single bond, and another double bond. So this is for conjugated. Okay? This is for conjugated. Double bond, single bond, and then double bond. So now what about cumulated? Cumulated dienes means that the double bond, after one double bond, there is another double bond. There is no single bond, then the next one, no. So after a double bond, there's another double bond. That is for cumulated dienes. But you can see that this structure, in this structure, is after one double bond, there's no double bond. Are you seeing it? So it means that this is not a cumulated diene. Now, what about isolated diene? An isolated diene simply means after a double bond, there are two or more single bonds before the next double bond. Okay? So for isolated dienes, we have a double bond, two or more single bonds before another double bond. So in this structure, this is the original structure, 1,5 hexadiene. As you can see, there is a double bond, single, 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 then double bond. So from the options, this is a what? This is an isolated diene. So this is an isolated diene. All right, the next question says, the addition of hydrogen to alkenes in the presence of a nickel catalyst is called dash. The addition of hydrogen to alkenes in the presence of nickel catalyst is called dash. Now, whenever you add hydrogen in the presence of a catalyst on alkene, it is called hydrogenation of that alkene. So the answer there is hydrogenation of alkene. Hydrogenation of alkene. That is the answer. Hydrogenation of alkene. Are you there? Now, the next question says, the addition of HBr, that is hydrogen bromide, the addition of HBr to 2-methylpropene gives mainly dash. The addition of HBr to 2-methylpropene gives mainly dash. So let us solve that on the board. All right. So, okay. All right. So the addition of HBr to 2-methylpropene will give us what? Please give me a second, please. Boy, how far now? My hand no good. Can I come here? Yes. Okay. Your people are they here? Are they here? I mean, your people here.
You never call here. I feel something for your level. I will say that how you talk at 10.
No. I even came by 11, sir.
Okay, you just started.
Yes, I'm just starting.
That means you can.
Yes, they can join. We're just starting. No problem. All right, sorry for that. So the question says addition of this to an alkene will give us what? Now, addition reactions in alkenes, especially in the case of a hydrogen halide. This is called a hydrogen halide because, this is a halogen and this is a hydrogen. So when you're adding a hydrogen halide or a polar molecule, such as water to an alkene, it follows or it may follow a rule called Markovnikov's rule. Okay? Now, from the idea of Markovnikov's rule, if you want to add this, HBr to this double bond, now, if the addition reaction will follow Markovnikov's rule, the hydrogen from the HBr will go to this carbon that has more what? Hydrogen. Then the Br, which is the bromine, will go to the carbon that has less hydrogen. Okay? So that is if you are following what? Markovnikov's rule. But if you are not following Markovnikov's rule, the reverse is then the case. Okay? Now, when there are scenarios where we don't follow Markovnikov's rule, and the first scenario where we don't follow Markovnikov's rule is if there is a peroxide present. Okay? Whenever you see addition of either a hydrogen halide or water. Or you see, in the presence of peroxide, immediately you see peroxide, you are no longer talking about Markovnikov's rule. Okay? So that is it. So in this case now, because there is no peroxide in this case, the product of this reaction will be in this form. All right. So this becomes the product of the reaction. So from the options, what answer is that? The option says 1 bromo, 2 methyl propane. No. 2 bromo, 2 methyl propane. Yes. So the answer is there. Option 2. It says 2 bromo, 2 methyl propane. Okay, this is second. Okay. All right. So that is the answer to this problem. All right. So the next question says ozonolysis of propene produces what? Ozonolysis of propene produces what? So ozonolysis is a kind of reaction for alkenes where the double bond is cleaved off. The double bond is cleaved off. So I'm going to illustrate it to you here. Plus, okay, into output. All right, now this is propene and this is ozone. Okay, ozone is O3. Now, when you react propene with ozone, it proceeds in 2 steps. The first step is the formation of an ozonide. Okay, first step is the formation of what? An ozonide. Then the second step is where the cleavage then occurs. And that cleavage step requires zinc dust. So I'm going to illustrate it to you on the board. So now, what happens is, look at what forms now. From this point, where this double bond is, look at what forms. All right. So this is the first step of the ozonolysis. So the first step is the formation of what? Ozonide. Now, this double bond, around this double bond, is where this thing is occurring. So over here, you know there are this CH2, but I don't just want to add all the other compounds to it, all the other substituents. So this is the ozonide first that have to be formed. Okay? Ozonide will first be formed around this double bond. Okay? Then after the ozonide have been formed, then in the presence of zinc dust, the cleavage then occurs. Now, if you're not following through all this process, the easiest way to get it is at this point here, at this point, you cleave this structure. Okay, you cleave it. Then look at what you're going to have. You're going to have two compounds. Cleaving means you're just like you're cutting something with scissors, that kind of thing. So at this point here, when you cleave it, you're going to have two compounds. You can see CH2 is here, and you can see that you can see two carbon here and one carbon here, right? So look at the two compounds that will be formed. The first compound will be, okay, allow me to write it down. Second one, I'll write it down because of space. All right. So this is the first compound plus all right. So this will be the two compounds that will be formed. So just imagine from this point here, this place is cleaved off. Okay? The double bond, one of the oxygen from here attaches to the double bond to form this. Then another oxygen from here attaches to the double bond from this carbon's end to form this. Are you seeing it? Now, what are the name of this compound? Now, you can see that we are having a methyl group, carbon, hydrogen, and then oxygen. Okay? Whenever you see a group in this configuration, you're talking about an alkanal. Okay? It's a carbonyl compound. The same thing here. Okay? The carbonyl compounds are two. We have the alkanals and the alkanones. Okay? Now, for the alkanal, you are seeing something like R. Okay? These ones for the alkanals. Then the alkanones, you're having something like RC to R. Okay? So this is alkanal. Then these are alkanones. All right. These are the aldehydes and these are the ketones. Okay. Underneath for them, aldehydes and ketones. Now, you can see now, when an aldehyde has two carbon, it is called what? Ethanal. And this one has only one carbon, therefore it is called what? Methanal. So the product of the ozonolytic cleavage of propene will produce what? Ethanal and methanal, or you can say methanal and ethanal. So those are the products of the reaction. So check your options. Check your options. Are you seeing methanal and ethanal there? So that is the correct answer. So this is ethanal and this is methanal. Okay? Are we there? So what is the next question? Okay, the next question says, that is V. Addition of water to ethane in the presence of sulfuric acid and mercuric sulfate produces initially dash. Addition of water to ethane in the presence of sulfuric acid and mercuric sulfate produces initially dash. So let us get the product on the board. Okay. All right. So back to the question. Addition of water to ethane in the presence of this produces initially. The answer is, you can see there. Can you see an enol there? Can you see there? Now that is the correct answer. That enol they put vinyl alcohol. That is the correct answer. Now in this case, the answer is this is called ethane. This is ethene 1,2 diol. So because of the double bond, okay? Ethene 1,2 diol. Ethene 1,2 diol. So this is a vinyl alcohol. Are you there? So the correct answer is that enol, vinyl alcohol. So the next question says, complete the following equation of reaction. They give us an equation of reaction and they say we should complete it. So let me write the first reaction here. All right, the equation of reaction is, all right. So this is the first part of the reaction, right? Now let's solve here first before we go back to the next side. Now what happens? This is ozonolysis reaction, okay? Ethene reacting with ozone. So what will be the product? We are going to first of all show the word ozonide, okay? Then before we proceed to the cleavage. So the ozonide will be in this form. So that first question mark, this is what you put, okay? That first question mark, this is what you put, okay? So, okay, I need to complete it with this H2. All right, so this is what you put in the first question mark. Okay? Then the reaction further proceeds under what? Zinc dust, water and zinc dust. All right. So water and zinc dust. Now, just like what I told you from the first problem, you can see that this thing we can cleave it from here, right? Now, when you cleave it from here, look at what you're going to have. You're going to have this. And also this. So these are the two products you're going to have, because if you cleave it from here, you're going to have one carbon with 2 hydrogen bonded to oxygen, then the second carbon with 2 hydrogen bonded to oxygen, just like that. So what are the names of this compound? They are both identical, okay? What is the name? Methanol. So we're going to have 2 molecules of what? Methanol. So this is the product of the reaction, 2 molecules of methanol. So in the other question mark, you draw the 2 of them, okay? Now try your best to maximize the space. You can see the space is very small, right? So try your possible best to maximize it so that you don't, start canceling. All right. The next one is, give the IUPAC names or structure of the following compounds. So they gave us some compounds. Let's give the IUPAC names and draw the structures. Now, hello, cyclic ring that has a double bond. Since it's a cyclic ring that has a double bond, it means this is what? Cyclohexene. So the first compound is cyclohexene. Cyclohexene. So the second one, so this is the second compound here. Now from the second compound, you can see we have three carbons, carbon 1, 2, and 3. And there's a double bond. So whenever we have a 3-carbon compound with a double bond, it is called what? Propene. It is called propene. Then the next one, they say we should draw pent2-ine. The next one, they say we should draw pent2-ine. So pent comprises of 5 carbons. So we go. All right, 5 carbons. And the ine simply means we are looking at a triple bond. So which carbon are we going to put is carbon 2. So if we are putting that carbon 2, let us take this as carbon 2. So I'm going to put triple bond here. All right. So we put triple bond here. Okay, I need to draw it again because of, okay, I think this is okay. All right, so this is the structure here. This structure of pent2-ine down here. Okay, pent2-ine. So that's the structure. Are you there? Okay, then the next structure is the same. You draw 2,4 dimethyl hexa 2,4 diene. 2,4 dimethyl hexa 2,4 diene. So they say we should draw this structure. So D. All right. So now it means that in carbon 2, there is both a double bond. Then in carbon 2 and carbon 4, there is both a double bond and methyl groups attached to this carbon. So it's hexa, so we're looking at a 6-carbon chain. So this becomes all right. So this is the compound on the board. Now you can see this is carbon 2 and this is carbon 4, okay? You can see there's a double bond with carbon 2, a double bond with carbon 4. And you can see the two methyl groups attached to it, okay? So this is 2,4 dimethyl hexa 2,4 diene. So draw it on your notes, please. That's the structure. All right. So that's it about question number 2C. So go over to page 2 of 3. Page 2 of 3 starts from question number 3. Question number 3A says, which of the following is a dihydric alcohol? Which of the following is a dihydric alcohol? Now, dihydric alcohol simply means an alcohol that has two OH groups, okay? So when there are two OH groups to the alcohol, then it's dihydric. In that case, you can see glycerol, you can see ethanol, you can see ethane 1,2-diol, you can see propane 1,2,3-triol. Now you can see from all of them there, it's only ethane 1,2-diol that is a dihydric alcohol. So the answer is ethane 1,2-diol because it has two OH groups. Now glycerol is an alcohol that has three OH groups. Glycerol has three OH groups. Okay? Glycerol has three OH groups. Now the next question says the reaction between an alcohol and a carboxylic acid in the presence of concentrated sulfuric acid, which is H2SO4, produces what? The reaction between an alcohol and a carboxylic acid in the presence of concentrated H2SO4 produces dash. So when an alcohol and a carboxylic acid react, it gives you an what? An ester. So you can see ester there, right? So the answer is ester. Are you there? Okay, so the next question says, when ethoxyethane reacts with concentrated HI, that is HI, right? Hydrogen iodide. When ethoxyethane reacts with concentrated HI, the products are, so I want to draw the reaction on the board so I can tell you the products. Ethoxyethane, which is diethyl ether rather, reacting with HI. So here's the reaction on the board. All right. So this is ethane, or you can call it diethyl ether. It's an ether, okay? Now, ether, they are characterized by this. You see this oxygen, hello? Now you can see as this oxygen is linking these two alkyl groups, right? Now those are what you see in terms of in ethers, okay? So this is called diethyl, one ethyl group and two ethyl group, diethyl ether. If you react with hydrogen iodide, you're going to have ethyl iodide and ethanol, okay? The product will be ethyl iodide and ethanol. So can you see any option like that? So we have an option that says ethyl iodide and ethanol. So that is the correct answer. So that is option 3 there. The next one is when a secondary amine reacts with a carbonyl compound, when a secondary amine reacts with a carbonyl compound, the product is dash. When a secondary amine reacts with a carbonyl compound, the product is dash. The answer there, okay, the options are imine, enamine, ester, and carboxylic acid. The answer is enamine. Enamine, okay? Enamine is the correct answer. Are you there? Okay, so the next question says, acid catalyzed hydrolysis of nitriles produces what? Acid catalyzed hydrolysis of nitriles. Nitriles produces what? Acid catalyzed hydrolysis of nitriles produces what? Now, what are the nitriles? Acid catalyzed hydrolysis of nitriles produces what? So this is what represents the nitriles, a carbon with a triple bond to nitrogen. So the answer there is carboxylic acids. Can you see there? Is it carboxylic acid there? Okay, answer there is carboxylic acids. That is the answer. Acid catalyzed hydrolysis of nitriles produces carboxylic acids. Are you there? All right, so what's the next question? Okay, next question is a reaction that is say we should produce the product. So let me draw the reaction. All right, so for that reaction, if the reaction is this, okay, if it's this, but I don't know if I'm seeing double, but if it's triple bond, right? So we're going to take it as a triple bond. So that reaction is saying the hydrolysis of that nitrile there that has 3 carbon, acid hydrolysis of that nitrile, just like in the previous question, they said acid hydrolysis of nitrile gives you what? Carboxylic acids, right? So that is exactly what I did here. So this is the acid catalyzed hydrolysis. Now, do you know what this thing means? Heat, exactly. So this is what? Heat. So it produces carboxylic acid, the corresponding carboxylic acid, and ammonium, please, and ammonium ion. Okay? And ammonium ion. Have you written it down? So just complete the reaction with this. Now, you see this particular ammonium ion, if you don't have space, no problem, don't write it. Okay? Are you following? If you don't have space, do not write it. You can just write the carboxylic acid. That's all. I'm saying because the answer sheet is very small. You can see the spaces are very, very, very small. And you would like to write it so that they will see your answer. So the examiner will see your answer. Question number 3C. Give the IUPAC names or structures of the following compounds. Give the IUPAC names or structures of the following compounds. So the first one there is that one too is a triple bond, right? Then NH. If it's a double bond, then this is what's meant to be there. Okay? If it's a double bond. So the first one there is called ethanimine. Ethanimine. So I'll write it on the board. So this is ethanimine. Are you there? So the next one is B. B is CH3, CH2, CH2, NH2. CH3, CH2, then NH, CH2, CH2, then NH2. So the name of this compound, the name of this is an amine. So how many carbon amine? 1, 2, 3. So this is propan 1 amine. Propan 1 amine. So this is propan 1 amine. So that is for B. The next one, they said we should draw propan 2-ol. So they say we should draw propan 2-ol. So this is an alcohol. Okay. All right, so propan 2-ol. This is the structure of propan 2-ol. This is the structure of propan 2-ol. All right, so what is the next one? The next one is methoxyethane. So D, we should draw methoxyethane. All right, methoxyethane, you start with a methyl group, then bonded to O, then CH2, CH3. So this is methoxyethane. This is methoxyethane. All right, so we are now in question number 4. Question number 4. The first question there says, okay, normally the instruction still remains tick the correct answer, and each question carries 1.5 mark. And the 4AI says, which of the following is a tertiary alkyl halide? Which of the following is a tertiary alkyl halide. So they gave us 1 bromobutane, 2 bromopropane. They gave us 2 bromo, 2 methyl propane, and they also gave us chloromethane. So if you look at the options, you know a tertiary alkyl halide is the one that is bonded to what? 3 carbons. A tertiary alkyl halide is an alkyl halide that is bonded to a carbon, which is bonded to 3 other carbons, right? Now, you can see the only option there that satisfies this is 2 bromo, 2 methyl propane. So that is the answer. 2 bromo, 2 methyl propane. All right, are you there? Next one. Reaction of an alkyl halide with excess ammonia gives mainly dash. Reaction of an alkyl halide with excess ammonia gives mainly dash. So what are the options? Reactions of an alkyl halide with excess ammonia gives mainly dash. The options are primary amine, secondary amine, tertiary amine, and quaternary ammonium salt. Is it primary amine, secondary amine, tertiary amine, or quaternary ammonium salt? So who knows the answer? Well, I know the answer. The answer is the primary amine. Primary amine is the answer. Primary amine is the answer. Have you gotten that down? All right. So the next one is the instrument used to measure the angle of rotation of plane polarized light by optically active compound is dash. The instrument used to measure the angle of rotation of plane polarized light by optically active compound is dash. Now, you can see options there. Polarimeter, spectrophotometer, refractometer, chromatograph. So which of them is the correct answer? So which is the correct answer? Now let me tell you now, you see that chromatograph. Chromatograph is used in chromatography. Okay? Chromatography is when you separate organic or when you separate substances due to their affinity for either the stationary phase or mobile phase. Then you see that spectrophotometer. No. Spectrophotometer absorbs light and measures the absorbance of light. So the promising answer, which is the correct answer, is the the polarimeter, please. Are you there? The polarimeter. All right. Moving on. The next question is the E/Z. The E/Z system of nomenclature. The E/Z, which is called the EZ system. The EZ system of nomenclature is based on what? You can see the options there, number of substituents attached to the double bond. The next one is the Kern-Ingold-Prelog priority rules. Kern-Ingold-Prelog priority rules, which is also known as the CIP priority rules. And you can see the other one is molecular mass of the compound. Then the other one is order of discovery. Okay, now E/Z is a nomenclature for naming compounds where there is no free rotation around the center or in the compound. For instance, an example of a compound that does not rotate is alkenes. Okay, alkenes do not rotate. So because they cannot rotate, the arrangement of groups around that double bond is very, very important in their naming. E means Entgegen. I don't know if I'm pronouncing it well, but it's German. Yeah. I think this is the correct spelling. And it simply means opposite sides. Okay? It simply means what? Opposite sides. Then the other one is Z is Zoo. I don't know whether it's one S or two S. Zusamen. You can check for the correct spelling if I'm wrong. Zusamen simply means same sides. Okay? Now, E is for engaging, Z is for Zusamen. Now, they are used. Now, if you want to use them, the most important thing is using the CIP priority rule. So the answer for that one is CIP priority rules, which is Kahn-Ingold Prelog priority rules. For easy nomenclature, what is most important is that Kahn-Ingold Prelog priority rules. Now, this easy system, we have two types in when we talk about naming alkenes. We have the easy and we have the cis-trans system, you know, right? Now, what cis-trans? Cis simply means same, trans simply means opposite. Now, we used to use cis and trans when the groups of interest are, when we have the same group, either on the same side or on opposite sides. Okay, for instance now, if we have something like this, you can see this is, the name of this compound is trans-2-butene, right? Sorry, this is cis-2-butene. You know why it is cis? Simply because the methyl groups are on the same side, upwards. You can see it, right? Now, this is when we use cis-trans. If the same group, let me see, this is methyl is of consideration here. The two methyl groups are either on the same side or on opposite sides. That's why we use cis and trans. Now, when do we now use E and Z? E and Z is when we have different groups. Okay, when we have different groups, let's say in place of this CH3 here, we have I. Then this one is CH3. But over here, we have Br, for instance. Here, we cannot use cis and trans, you know, right? We can't. So this is where the E and Z system comes in. Now, the E is talking about, okay, the Kahn-Ingold Prelog priority simply means for each of the side, like for each of the carbon, in this case, this carbon and this carbon, we are going to identify the group of higher priority. In this case now, iodine has a higher priority to hydrogen. You can see it here, right? Then in this case, bromine has a higher priority to what? Methyl group. You can see it. So because of that, this we are going to use, since the iodine and bromine are opposite sides, we are going to name it using the what? The E naming system. Okay? So the most important thing here is the Kahn-Ingold Prelog priority rules. First of all, identify the groups on the left side, identify the groups on the right. Then assign priority. The halogen will always have priority over hydrogen and methyl groups. Okay? Now, when you have known that, then you cannot decide now. You can see now the two priority groups are opposite sides. So because of that, you use the what? E naming. Because E simply means what? Opposite. Then you can start assigning the what do you call it? You can start assigning the numbers. You can start naming them according to alphabetical order, the way you used to do normal naming. Okay? So that's what we use. So the Kahn-Ingold Prelog priority rules are the ones we use in this kind of naming. All right, so that is the answer for that question. So what is the next one? The reaction of propanone. The reaction of propanone with water gives you dash. Is that propanone there? The reaction of propanone with water gives you dash. Are you there? So let us draw the reaction on the board. Let us draw the reaction on the board. I don't know what I will take down. Something to clean. All right, so the reaction of this is propanone and this is water. The reaction of propanone, you can see the double bond, which makes it propanone, and water will give you this compound here, okay? Will give you this compound. Now, what is the name of this compound? The name of this compound is propane 2,2 diol. The name of this compound is propane 2,2 diol. You can call it propan 2,2 diol, okay? Now, this kind of diol is called a geminal diol, okay? It's called a what? Geminal diol. Now, geminal diol are both the two OH groups are on the same carbon, up and down, okay? Why vicinal? When you have vicinal or vinyl, it means that they are the same. They're just like they're neighbors. Vicinal, you see OH here and OH here. Are you saying it? That's for vicinal. Then geminal, you can see it here up and down. So this propane 2,2 diol. And this, if you look at the option says a what? Using a gem diol. Gem diol is the answer. Geminal diol. Okay, number 4B says they gave us some compounds and they say we should use cis or trans, E or Z, and give the IUPAC names of the compound, right? They gave us cis, they gave us some compounds, either we use easy or we use what? Cis trans to give the IUPAC names. So let's start from the first one. All right, so they say we should name A, B, C, D, and E using cis trans or easy system. So that's what we want to do now. All right, so for A on the board, I've told you want to use cis and trans, right? And I've told you want to use what? E and Z. So I'll take it again. You use cis and trans if we are looking at the same group on either same side or opposite sides. Then you use E and Z when we have more than one group or different groups in either the same side or opposite sides. But most importantly, for E and Z, Kern-Ingold pre-log priority system must be, it must add the idea of Kern-Ingold pre-log priority system of naming, okay, into the E and Z pattern, okay? All right, so let's start from the first one. Look at this now. We're having two groups, methyl and fluorine. Now, want to name it, should we use cis trans or easy? Cis trans. Why? Okay, why do you say cis trans? Because what? Okay. Because we're dealing with the same group, right? Okay. That makes sense. That makes sense. But now we're having both methyl and fluorine. Same groups, right? On same side. So are you saying we're going to say cis methyl and cis fluorine at the same time? So what are we going to do? Now, the truth is this. If you use cis trans, if you use cis naming, and you focus on the fluorine, you're correct. But using IUPAC standard, you can see that here priority will matter because we are dealing with both fluorine and methyl. So it means the priority here matters a lot. Are you following? So because of that, we're going to make use of the word easy naming. Are you following? Because of what? IUPAC standard. If you see cis now, cis, you talk about the positions of the fluorine, okay. But following acceptable IUPAC standard, we are going to use the word Z naming. Do you get that? I hope you're on the same page now. Okay. So I will advise you just give it two names. Just give it two names. Because both of them are correct, but one is IUPAC standard, which is generally acceptable. So for me, I will use just Z. Okay. Now this becomes, because the fluorine is on the same side, we give higher priority to fluorine instead of to methyl groups. So this becomes Z hyphen. Here we can see that this is 1, 2, 3, 4. So the fluorine is at carbon 2 and carbon 3. So Z 2, 3 die what? Fluoro hyphen. Then no need for the hyphen. Then we have what? Boot. The double bond is at carbon 2, right? So it becomes boot 2 in. Boot 2 in. So 2Z 2, 2 difluoro boot 2 in. Which other one again? Which bond? Is any other one? It's complete now. All right. So the name goes with Z, 2 bromo, 1 fluoro, 1 iodo-propene. So now we have 2 left. So over here, you can see this. You can see now we have hydrogen, hydrogen, this group and this group, right? Now, what is this group called? A what? L2 group, right? Thank you. So if you want to let's number this carbon, it becomes carbon 1, 2, 3, 4, 5, 6. All right. So now we can see that we're having ethyl. Now here we don't need to assign higher priority, right? That means we're going to use the C trans naming, right? Now we're going to use the C trans naming. C trans. Because they're going to assign higher priority here. Okay? So what will be the name of this compound? This will be, first of all, it will be what? Trans. Now, here, don't say trans ethyl. No. No, please. Yeah, the next thing I'm going to do is, after trans, you're going to look at the position of the double bond. You know, the groups here are ethyl groups, okay? Whenever the group is methyl, ethyl, don't mention the ethyl or methyl. Are you following? So in this case now, we're having ethyl and methyl, so then there's no need to mention them. They form part of the longest continuous carbon chain. So we need to mention it. So here we're having trans. What position is the double bond? 3, right? So it becomes trans 3 hexene. Trans 3 hexene. Okay? Trans 3 hexene, please. All right. Now, you know that this is correct, but sometimes, you know, from IUPAC plenty rules, sometimes they'll say that we should put the hex before in, something like that. Okay? So this can also be trans hex 3 in. So it can be either way. The both of them are still correct. But for exam's sake, let me just advise for exam's sake, take the second one. Okay? For exam's sake, take the second one. Okay, now we are the last one. The last one has CH3 and bromine on one side, of which in the other carbon we have CH2, CH3 on the other side together with hydrogen. So now we have to assign priorities because you are seeing that we have a bromine group here, right? So we have group 1, group 2, and group 3. So we have to assign priority. Okay? All right. So now, of course, on this carbon, this priority comes to what? Bromine. Now on this one, the priority comes to this guy too, this ethyl group. So how do we name this? Now to name this, please don't mention the ethyl once again. Okay? The ethyl forms part of the parent chain. So don't mention it. So you can see that the priority groups are on opposite sides. So this becomes, since they're on opposite sides, this becomes what? E. Now let's number the carbon. 1, 2, 3, 4. Right? 1, 2, 3. Okay. I didn't number it well. 1, 2, 3, 4, 5. All right. Now we can see that the double bond is at carbon 2. Okay. So this becomes E. All right. Now since it's E, the next thing is to identify the carbon that bromine is attached to, right? Bromine is attached to what? Carbon 2. So you can call it E2 bromo Then this is a pentene already, so you can call it 2-bromo-pent. Pent. You can see the carbon 2, the double bond is at carbon 2, okay? So it becomes pent 2 E. 2-bromo, E2-bromo, pent 2 in. So that is the name of this compound. Okay, so I said that the cis and trans is used when we have the same group, okay, located either on opposite sides or on the same sides around the carbon sharing the what? Double bonds. So in the cis and trans, we are looking at the same group. The group can be either just iodine, which is I and I, located either on the same side or on opposite sides. Then for the E and Z, we said E is means what? Engaging, which also translates to opposites. While Z is Zusamen, which translates to what? Same side. So for the E and Z, you look at when there are different groups attached to the carbons sharing the double bond. So for this E and Z, you can see iodine, bromine, fluorine, or you can see iodine, bromine, methyl, and ethyl. Okay, you can see it in E and Z. So you now start attaching. Now, when you see it, the first thing you consider the first carbon on the left, which is sharing the double bond, like what you did here. This is the carbon on the left. You look at the two groups attached to it. The two groups now, you look at, let me say you have iodine and you have methyl attached to the carbon on the left. You give the higher priority to what? To the iodine. Then on the other side, let's say you have bromine and you still have another methyl. You give the higher priority to what? To the bromine. Then when you have done that, you then look at these groups of higher priority. Are they on the same side or they're on opposite sides? Okay? So that will now tell you whether it is E or Z. Then when you have done that, the next thing you have to do is to start, you now number the carbon, making sure that the double bond gets the lowest possible number. With that, you can now use that to finalize the naming in alphabetical order. Okay? So that's how you use the E and Z. Please do not mistake cis trans for EZ during exams. Okay? Do not mistake it. So that is it. Do we have a question again? We don't have a question, right? All right. All right. So C tells us that the next one, which is 4C, it says we should circle the stereogenic / chiral carbon in the molecules below. So they gave us some structures and they say we should circle the word chiral carbon. So I'll draw the structures on the board. All right. Now they gave us these five compounds, and they say we should circle the what? Stereogenic or the chiral centers, right? Okay, so let me tell you what a chiral center is. A chiral center, okay, let me just tell you what a chiral carbon is. A chiral carbon is a carbon that is bonded to 4 different groups. A chiral carbon is a carbon that is bonded to what? 4 different groups. 4, not 3, not 3.5. 4 different groups. That is a chiral carbon. And every chiral, where you see any chiral carbon, at that spot where that chiral carbon is called a what? Chiral center. Or you can call it a stereogenic center. Now you see that chiral center, it rotates plane polarized light. Okay? That chiral center rotates what? Plane polarized light. Are you following me? Okay, so you need to know that. So now we need to circle where is the chiral center. We need to locate it and circle it. So for A, this A now, you ask yourself, where will I even start from? I hope you understand your skeletal structures very well. All right, so you notice that this carbon now has 2 hydrogens, right? So since it is bonded to, 3 hydrogens, since it is bonded to 3 hydrogens, it cannot be a chiral carbon. So these 2 are out of it. These 2 are bonded to 2 hydrogens each. They cannot be a chiral center. This particular one has a double bond. It cannot be a chiral center. Same thing here. It cannot be a chiral center because of the double bond. Over here, this is bonded to 2 hydrogens, so it cannot be a chiral center. This has 2 hydrogens, it cannot be a chiral center. This has 2 hydrogens, it cannot be a chiral center. What about here? Now, this is bonded to this ethyl group, is bonded to the other part of this chain, to the left. Downwards, it is bonded to this other part of this cyclic ring. Then upward, it is bonded to what? Hydrogen. So because of that, this is a chiral center in this compound. This is the chiral center in this compound. The carbon here, because it's bonded to 4 different groups. Okay? Now, over here, where is the chiral center? The chiral center is already looking at us, right? Now, you can see that this one now is bonded to ethyl. This carbon now is not a chiral center. This is not a chiral center. But this is a chiral center. Why is it a chiral center? Now, you look at here, it is bonded to ethyl group here. Over here, it is bonded to everything to the right. Okay? Then look at here. Up is bonded to hydrogen, down it is bonded to OH. Right? So because of that, this is a chiral center. So they say we should circle only one, right? From the question, the instruction says circle only one. Okay, what about here? Over here, we can see that this is not a chiral center, this is not a chiral center, this is not a chiral center, but this is a chiral center. Now, the chiral is not K, it is CH. Okay, so please don't call it chiral. No. Okay, what about here? Here already, we already seen the chiral center looking at us, right? So which spot? This is the chiral center. Over here, the chiral center is still looking at us. This spot here is the chiral center. I've told you that the chiral center is the stereogenic center, and the stereogenic center is where is that center or that spot where the carbon is bonded to 4 different groups, right? And I told you that center rotates plane polarized light. Now we have 2 types of optical rotation of plane polarized light. The first type is called the D rotation or dextrorotatory. This is called dextrorotatory or D rotation. This is to the right. Okay? Dextrorotation is to the right. Then the other one is levorotatory, which is to the what? Left. Okay? So this is to the right. This is to the left. So this is dextral rotation and level rotation. So these are the types of optical rotation. Hope you got that. So please take note of it. Even though you cannot remember the D and L, just call, even though you cannot remember the full meaning of the D and L, just call it, even though you cannot remember the dextral and the level rotatory, just call it D and L. D is to the right, L is to the left. That's why when you start doing biochemistry, you hear something like D glucose and L glucose. People know if you always hear D glucose and glucose D, right? That means that that particular isomer of glucose rotates the plane polarized light to the what? To the right. Yeah, that's why it's called glucose D. There's glucose D and there's glucose L. So any compound that has two optical isomers or optical isomers, that compound exhibits optical isomerism, also known as stereoisomerism. I think I've done that in class before. They've not told you about stereoisomerism before. Okay, they have. Okay, they haven't. Maybe Tuesday is the exam, right? Okay, on Monday. For this, chemistry. Okay, so on chemistry, you know whether they have or they haven't. All right, so that is 2 of 3. Now we are at the last page. We are at the last page. All right, so number 5, question number 5A says, which of the following is not an alkanoic acid derivative? Which of the following is not an alkanoic acid derivative? We have acyl halide. Acyl halide is there. We have an amide. We have acid anhydride. Then we have alkane. Please, alkane is not a alkanoic acid derivative. So the answer there is what? Alkane. So the rest of them are alkanoic acid derivatives, please. All right. The next one is the product of esterification of ethanoic acid and methanol is the product of esterification of ethanoic acid and methanol is, will give us what? So should I give this on the board? The reaction, okay. Let's give the reaction on the board. So this, it said ethanoic acid. Is it ethanoic acid? Ethanoic acid, right? Plus what? Methanol. All right. So this is okay. So the reaction between ethanoic acid, this is ethanoic acid, and this is methanol. And this is in presence of H2SO4. All right. So in the presence of H2SO4, ethanoic acid will react with methanol to give you what? Methyl ethanoate. Is it part of the options there? So this is the answer, methyl ethanoate, please. Okay, so that's it. So the next one is when a hydroxy group and a double bond are present in the same compound, the compound is named with the suffix, here you can see in, that's hyphen in, you can see hyphen ein, you can see hyphen all, and you can see hyphen in. So you can see hyphen in, then ein, all, and in. So when there is a double bond and OH, okay, it becomes an enol. So the hyphen we are going to do here is what? All. All of the above. All. So all is the suffix of consideration here. Okay, D says, which of the following is not a general property of metals? What is not a general property of metals? First option says, metals are good conductors of electricity. Is that a general property? Yes. Metals are malleable and ductile. Is that a general property? Yes. Metals have high tensile strength. Is that a general property? Yes. Then metals are poor conductors of heat. Is that a general property? No. So the answer is what? Poor conductors of heat. So that is not a general property of metals. Okay, are we there? E says chlorine is obtained industrially by the first one says electrolysis of molten alumina. Is that the method of obtaining chlorine industrially? No. The next one says electrolysis of brine. Is that the method of obtaining chlorine industrially? Yes or no? Yes. Actually, electrolysis of brine is the method of obtaining chlorine industrially. Now, you know why? You know what brine is? Brine is a solution of sodium chloride. So whenever you use electrolysis, you're going to separate the sodium from the what? Chlorine. So that's how we obtain chlorine industrially. Electrolysis of brine. Okay, the next one gave us an equation. It gives us an equation of reaction. So the question, from the question, it gave us this and gave us a question mark here, right? So it said we should find the word product. So we should find the product. All right. Now, the reaction is the reaction between methanol and water. That is, you are trying to add water to what? Methanol in the presence of hydrogen chloride. Now, in the presence of hydrogen chloride, the product of this reaction will be methane 1,2-diol. Now, this kind of diol, what do we call it? I told that there's a name we call this kind of diol. What do I say we call it? Geminal diol. Okay? Which is gem diol, right? So this is the answer to that question. This is the answer to that question. Okay, so the next question says you give IUPAC name of some compounds. Either we give the IUPAC name or we draw the structures, right? Okay. Let me pause. Okay. The next question says that we should give the IUPAC names or we should draw the structures, right? So we have these compounds. So the first one is propanoic acid. So let us draw propanoic acid. Propanoic acid contains 3 carbons. So it gives us CH3, CH2, COOH. Now you can write COOH, but I think if you write it right, you're not even drawing it. So just please try your best to make it look like this. Just try and maximize your space. All right, so this is propanoic acid. This one, in the section, name this. You can see that this is an ester, right? Because you're having OO. So it's an ester. So what kind of ester is this? You name ester, first of all, you name this side after this oxygen. You name here as an ethyl, as an alkyl. Then you name this other side as an OH. That's how esters are named. So this one now contains 2 carbon. So it is called what? Ethyl. Now, it is ethyl. So let's look at this other side. This other side contains what? 2 carbon. You can see it, right? So since it's ethyl, since it's 2 carbon, you name it as an OH. So it becomes ethyl ethanoate. So I'm going to give a space. Ethyl ethanoate. All right, so that is for that one. Then this one, they say we should draw methanol. Methanol is central carbon doubly bonded to hydrogen and singly bonded to doubly bonded to oxygen and singly bonded to 2 hydrogens. So this is methanol. Then this one, they say we should name this one. This is you can see the double bond to oxygen points us to the carbonyl compound. But which kind of carbonyl compound will this be? This definitely has to be a ketone because of the double bond to oxygen and alkyl groups on the left and the right. So what ketone is this? You can see, let's count the carbons. 1, 2, 3, 4, 5, 6. 6 carbons. But you can see that the oxygen is located at carbon 3. 1, 2, 3, 4. Okay, 1, 2, 3. It's located at carbon 3. And you know how to name ketones. Ketones, if the doubly bonded hydrogen is at carbon 2, you just name it as hexanone. Okay? But if it's at carbon 3 or any other carbon position that is not carbon 2, in this case, you have to assign that double bond a name. That you have to assign it a position. Okay? So this position is position what? 3. Okay? I should take it again. Okay. I said that when you are naming ketones, if this double bond, for instance, now, let's ignore here. Let's say it's at this point now. This is carbon 2, right? This double bond to oxygen. Let's say it's carbon 2. Let's ignore this one up, okay? Just ignore it. So let's say it's at carbon 2. If it's at carbon 2, this name will not be 2-hexanone. No. You just go ahead to name it what? Hexanone. Are you following? That's how you name ketones. But when it is not in carbon 2, let's say it is in carbon 3 or carbon 4, depending on how long the chain is, right? You have to take notice of that position. You have to take notice of the position. So in this case now, it is at carbon 3. You can see it here. So since it's at carbon 3, this becomes hexan 3-one. So this is the name of this compound. That's how you name ketones. Okay? Do you understand that? Okay, so that is it. So we are finishing gradually. Is that the last one? Yes, that is the last one for number 5. So now the next one is number 6. So number 6. We have to start with 6A. 6AI says, alkaline metals react vigorously with water to give off which gas? You know what alkaline metals are, right? All the metals in the first period of the periodic table. So the first group of the periodic table, not period, please. All the metals in the first group of the periodic table. Sodium, potassium, they are alkali metals. Okay? So whenever alkaline metals react, if you throw sodium inside water, have you done that before? Okay, if you throw sodium inside water, you will hear a spark. Just like you want to bomb the area. You'll be feeling like you want to bomb something. All right. So if you put alkaline metals with water, a gas is given off. That gas is called hydrogen gas. So the answer is hydrogen gas, which is H2. II says, which property is characteristics of transition metals? Which property is characteristics of transition metals? The first one says low melting point. Low melting point. Which properties is characteristics of transition metals? The transition metals have low melting point. You know it's not strong. Do transition metals have high melting points? Okay, people don't even know what transition metals are. I assume people don't know. So transition metals are on the D block of the periodic table. Okay? They are on block D. Example, zinc, nickel, cobalt, iron. Which other one again? Manganese, chromium. Which one again? Okay, you know them now. Copper. They are all transition metals. So D block on the periodic table is where you find them. So transition metals don't have low melting point. Does zinc have low melting point? No. So that one is scrapped out. The next one is lack of catalytic activity. The truth is that transition metals are the most used catalysts. So they have very good catalytic what? Activity. For instance, nickel catalyzes the hydrogenation of alkenes. Okay? So that one is scrapped out. The next one is variable oxidation states. Transition metals have variable oxidation states. Example, iron has ion 2 and ion 3. So the other one is inability to form complexes. So that variable oxidation state is correct. Okay? So they have what? Variable oxidation state. So that one is the correct answer. Why the last one, inability to form complexes, although it is wrong. Transition metals have ability to form what? Complexes. In fact, they are the highest formers of complexes. They love forming complexes. Okay? So that is it. Now the next one. Nanochemistry is the study of what? Nano, when you hear nano, nano means something that is very, very small, right? Super tiny. So nanochemistry, we are looking at chemistry of studying nano particles, right? So the answer there is chemical phenomena at the nano scale. Chemical phenomena at the what? Nano scale, which is the last one. This is the answer. Then number 4, the following methods are used for the isolation and purification of organic compounds, except, so which of these methods is used in isolating and purifying organic compounds? So we have filtration. Yes, we can use filtration to isolate and purify organic compounds. So we can use filtration. The next one, chromatography. Yes, we can use chromatography to separate organic compounds. Then we have crystallization. Yes, we can use crystallization. The other one, that is classification, is the answer to that question. So classification is the answer to the question. The next question says, the instrument used to determine the molecular weight and fragmentation pattern of an organic compound is dash. The instrument used to determine the molecular weight and fragmentation pattern of an organic compound is dash. Now you can see infrared spectrophotometer. That is wrong. You can see mass spectrometer. That is the correct answer. Mass spectrometer. Why the other ones are wrong answers to the question. So mass spectrometer is the correct answer. Are you there? Then the other one is state, that is 6B. State whether the following properties are true or false about transition metals. So we want to know which one is true and which one is false. So the first one, they have variable oxidation state. Do transition metals have variable oxidation states? Yes, the answer is what? True. So that's for I. They have low boiling points. Do they have low boiling points? No. So that one is what? False. Then I, their compounds are often colorless. Are their compounds often colorless? No. They actually have colors in compounds. You know, right? So transition metals have colors in compounds. So that one is false. Then they form complexes. Do they form complexes? Yes. So that one is true. So that's the answer to that. Then finally, 6C. 6C says, mention the names and give symbol of any two transition metals. So that one is like, they're just giving you bonus mark, you know. So let us give two transition metals. The first one is nickel. Nickel, the symbol is Ni. Then we have iron. Fe. Please, you can write ferrum or iron. No? Fe. So these are two transition metals. If you want to give, please don't give them more than two. I know you know it. I decided to give them their two that they asked for. Okay? So with this, we are done with Chem 102 exam revision. So I'm going to give you 5 minutes. 5 minutes to go and drink water and come back. Then we're going to do Chem 108, that is practical, and physics practical together. So just 5 minutes break, just 5 minutes break, 5 only. This is, what's time? This is not correct. So I'll see you in 5 minutes time, 2:15.